Ladies and gentlemen, welcome to Module 11, IP version 4 addressing. My name is Mr. Tandy at Tandy IT. So I want to show you this awesome picture really quick. So you just show up on the job. You are a network tech. You just passed your CCNA, you just got your network plus, did all those good things. You show up to the job and the boss says, hey, welcome. But we have a little issue here. We've only been given one IP address, which is on the WAN side of things from ISP. However, this is the IP address that we have to work with: 192.168.1.25. But here's the issue: we have over 400 addresses. We have 400 items, IoT devices, printers, uh, IP cameras, security systems, laptops, iMacs, PCs. Like there's a whole bunch of connectivity issues we have here, right? Not issues, excuse me. A whole bunch of things that need to be connected to this network, but we have to work with this IP address. So how are we going to do that? How are we going to do that? This video we're going to take a look at to see how we can make that magic happen using the magic of subnetting. Okay, so here we go. Module objectives: we're going to calculate IP version 4 subnetting scheme to efficiently segment your network. IP version 4 address structure: describe the structure of the IP version 4 addressing, including the network portion, the host portion, and the subnet. You're going to see me bring back some old pictures from some of my earlier videos. Unicast, broadcast, multicast, we're going to go over that. Types of IP version 4 addresses: public IP addresses, private IP addresses. Network segmentations, how are we going to actually do the subnetting? I'm going to show you how I do the subnetting and how we can calculate all the different subnets. IP version 4 address structure. An IP version 4 address is a 32-bit address, hierarchical address, that is made up of the network portion and the host portion. Okay? So when determining the network portion versus the host portion, you must look at the 32-bit bit stream. And the subnet mask is used to determine the network and the host portion. So very important. We're going to get into a lot of this here because this tells you what the network portion is, or essentially the network ID, and this is going to tell you what the host bits. So one part is going to be static, the other side is going to be very, very dynamic, very, very dynamic. By the way, here's your lecture question. On a WAC 24, how many hosts can we have on one network? Email me that. Let me know what you think. You may not get the answer to that until after you watch this video, so I want to get that email from you. Let's continue. To identify the network and host portions of IP version 4, the subnet is compared to IP version 4 bits by bit from left to right. So let's take a look at this here. Now, if you remember in our bit stream, I'm just going to go ahead and write it here. We did this a little while ago when we were doing the binary stuff. We have our, we have 128, 64, 32, 16, 8, 4, 2, and 1. Okay, so we have 8 numbers, represents the 8 positions of the numbers, and this is our octets, right? We have 8 octets with our bit stream. So if we have a number that is on, right? If we have a number that is on, for example, this number is on, therefore it's 128. That bit stream is on, so this is going to get a 1. This bit stream is on, it's going to get a 1. Everything else is 0. 128 plus 64 equals 192, and that's how we get the 192. Okay, so subnet mask is the same way, right? If we have all of the numbers on, if you were to add every one of these numbers up, we are going to effectively get 20. We're going to get 255. That's going to be our deal there. We're going to get 255. So let's continue here. So you may have noticed earlier in my video, you saw IP address of 192.168.1. I think it was with a WAC 24, right? Those WACs are essentially how many bits are on for the subnet. Okay, that's how many bits that are on for the subnet. So, for example, as you can see here, we have 1 octet, 2 octets, 3 octets, right? 4 octets, okay? Each are divided. So if we have 8, that means we have 8 bits that are on. Everything else is off after the 8. WAC 16, first 2 octets are going to be on. The last 2 octets are going to be off. If we have a WAC 24, first 24 bits are on. Everything else is going to be off. And then 25, 26, 27, 28, 29, all the way to 30. So these numbers represent the subnet mask, and it tells you how many bits are on. Very, very important. So essentially, it's a lot easier than writing 255, 255.255.0. You can just put it in the notation WAC and then the number. So next slide, you're actually going to see that, as you can see here. As you can see, we have our regular IP address. This is 8 bits that are on, 8 bits that are on, 8 bits that are on. So we have 24 bits that are on. The rest of the bits are off. So therefore, for this particular subnet, okay, we're looking at this would be a WAC 24 because we have 24 bits that are on. Very, very important. Now, before we get into the next part, I want to make sure you all understand this because this is super, super important because it took me a while to figure this out when I started getting into this, but it is very important that you understand this, okay? When it comes to dynamic versus hosts, okay? Dynamic versus hosts. It is very important. The subnet mask, okay? Let me circle this thing because that's how important this is. The subnet, let me go back. I lost all kind of things here. I am not doing good here. Apologize for that. Okay. The subnet mask determines the network portions and the hosts. It is very, very important you understand that the subnet mask, whatever numbers are on top of the subnet mask that represents those octets, these numbers are static. They cannot move. They cannot move. These numbers will stay like this. So for this example, it'll be 192.168.10, okay? And then everything after this are the host bits. These numbers are going to be dynamic. But no matter what your IP address is, in this particular case, we have a 255.255.255, which is a WAC 24. So the first 3 octets are not going to change. So the very, very last IP address on this network, which would be considered the broadcast, because remember, you're supposed to reserve 2, one for the network ID, one for the broadcast. Even the broadcast is going to have 192.168.10, and then these numbers here, these numbers are going to be dynamic. Very, very important. Make sure you understand that the subnet mask determines the network portion. So if those bits are on, then everything is good to go there, as long as those bits are on. Put my laser pointer back on. Let's get going here. All right. So I need to do that. All right, let's continue here. Within each network are 3 types of IP addresses. We have the network address, host address, and the broadcast address. We kind of just got into that. So each IP address is going to have the network ID, and then you're going to have a broadcast. Those 2 IP addresses are reserved, okay? Those 2 IP addresses are reserved. As you can see here, this is the network portion. Everything past the network is zeros. And then if it's a broadcast, everything past the network portion is going to have a bunch of 1s, which means everything is on. So let me show you that more in detail. So I'm just going to put a random IP address up here. We're just going to go 10.10.34.6, and we're going to give it a WAC 24. So if you remember, I told you in the last couple slides, the WAC 24 signifies the subnet. Okay, very important. The subnet determines our network side versus our host side. The network side, network portions do not change. Very important. So, in looking at this, we can see if we take our numbers here, okay, if we take our numbers, we have a WAC 24. So what I like to do with our WAC 24, we're actually going to put that in binary. And I'm giving you just a little precursor to how we do our subnetting. So I like to do this in binary. So I like to put the 24 in binary. So we're going to draw these numbers out. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, okay, 9, 10, 11, 12, 13, 14, 15, 16. There we go. And then 17, 18, 19, 20, 21, 22, 23. There's our 24. There's our magic number, 24. And then everything else after that is going to get zeros. 4, 5, 6, 7, and 8. Those are zeros. So I like to take my little line signifying the network side versus the host side. And this is how we write out 24, or WAC 24, in binary, right? So if we add up every one of these numbers, that's going to lend us a subnet mask of 255.255.255, and then the last portion is going to be 0 because these are dedicated for our host bits. Let's do another one so you can kind of get a little feel for this. Let me actually grab my eraser, and we're going to keep that same IP address up there. The only thing we're going to do with that IP address is we're going to change the subnet mask. We're just going to call it a WAC 16. Let's give it a WAC 16. So now that it's a WAC 16, okay, now it's a WAC 16, let's get rid of these. And I'm pretty sure you've guessed it by now. If not, it's okay. Now this is a WAC 16. The first 2 octets are on. So that means everything else past that is going to get zeros. 2, 3, 4, 5, 6, 7, and 8. And our network line is going to go right here. So let's make sure we keep everything the same here. Oh, I just lost my network line. Let's go back here. Let's draw a network line. And this is going to be a 0. Very important. This is going to be a 0. A little bit later in this video, I'm going to show you how to find the network ID and the broadcast ID of any IP address, because you're going to need to understand that when it comes to the subnetting part. Okay? Moving on. IP version 4, unicast, broadcast, and a multicast. So let's go through these. Unicast transmission is sending a packet to one destination IP address. So essentially it's just between you and one other person. It's between you and that person. It's just a unicast. Nobody else hears it. It is just between you and that person, or those 2 nodes that are talking. Those 2 end devices. A broadcast is basically saying, hey, everybody, hello, I can hear you. Can everybody hear me? I am looking for such and such. Can somebody help me? That's a broadcast. Multicast sends it to certain machines. Not all, but a couple of computers. Okay? So again, unicast is between one machine and one person, or one machine, one end device, and another end device. A broadcast, everybody is going to get it. Everybody is going to get it. And then multicast, only certain machines get it. Only certain machines will get the packet. As you can see here, for example, PC 172.16.4.1 sends a multicast packet to multicast group address of 224.10.10.5, right? Types of IP version 4 addresses. So as defined by RFC 1918, public IP version 4 addresses are globally routed between internet service providers, your ISPs, Spectrum, okay, let's see here, Verizon, things of that nature, some of those companies that are out there. Private addresses are common blocks of addresses used by most organizations to assign IP version 4 addresses to the internal hosts, okay? Private IP version 4 addresses are not unique and can be used internally within any network. However, private IP addresses are not globally routable. So network translation provides IPv4 addresses to the public. And I'm going to show you a picture of what that looks like here in a second. NAT is typically enabled on the edge router connecting it to the internet. It translates the internal private IP address to the public IP address. So let's take a look at that. Let me show you what that actually looks like. Just put the word up here, NAT. That way we know what we're kind of talking about. It stands for network address translation. All right. So let's just say, for example, we have a wonderful house. Now, don't judge me. I am not a big drawer, but we'll make it work. This is kind of a lopsided house, but it's okay. We'll call it a house. So what's typically inside of a house nowadays? Okay, typically inside of a house. Okay, we might have, let's divide into floors. We may have our smart TV hanging on the wall right here. Maybe downstairs in the office is probably going to be a PC. Maybe another smart TV sitting right here. Maybe outside of the house, there's going to be some cameras. Maybe like a Ring camera. Let's put another Ring camera on this side of the house. Okay. Like closed circuit type cameras or whatever. Let's go upstairs. Maybe the PlayStation is upstairs. Okay. We'll call this a PS5 or something. Okay. If you guys are following me here. And then downstairs, we'll put like another big TV down here. This would be like a little smart TV, and then let's put a smart refrigerator in here. Okay, so here we go. We have our house, and it has some IoT devices in here. So what I'm going to do is I'm just going to draw a line, a little imaginary line. Okay, this is going to be our little post office line, and we're going to give this a IP address of 74.35.16.14. And I'm going to put these three words, the three letters on the end of this. Wide area network, right? Wide area network. So this is the IP address that has been given by a typical ISP. It could be Spectrum, it could be Verizon, whoever your ISP is. This is going to be the WAN address. So on the WAN side of things, on a wide area network, they see this house using this IP address. But how does it work? We only have one IP address, but we have how many machines? How many IoT devices did I say in here? We had 1, 2, 3, 4, 5. We had like over 6 or 7 IP addresses or things that need to have internet. They all cannot share this WAN address. So network address translation. Let's take a look at it. So what it does, it's going to take an internal IP address, and you're going to use a basic IP address inside, and it's going to translate from the internal IP address to your exterior, which is going to be your WAN address. So, for example, let's call this TV 192.168.1.2. Okay. And I'm just going to go right around. I'm not going to fill out the first 3 octets. We're just going to call the PlayStation a .3. We'll call this camera a .4. We'll call this computer a .5. This TV is going to be a .6. This refrigerator is going to be a .7. And let's call this computer a .8. And this other camera over here, we'll call this a .9. And this TV hanging on the wall right here, we'll call this a .10. Now, one other thing I want to do, I want to add just a little router right here. Here's our little router, internal router. And we're going to give the router actually a .1. We'll give that a .1. So our router is a .1. Okay. Let me put on here router. Okay, so here's our router. Still need a router inside the house so you can move things in the internal subnet here. Okay, so the internal IP address 192.168.1. Okay. actually .0. That's actually the network ID. We'll get into that. I'll explain that to you. We're going to call this a WAC 24. So therefore, the first 3 octets are on. So every one of these IoT devices have the first 3 octets that are 192.168.1.2. So when every one of these devices wants to access the internet, okay, before it can go out, it is going to hit the router. The router is going to send a signal to the WAN side of things, and it's going to translate into this IP address, just like that. And then when incoming traffic comes in, okay, it essentially translates back, where you may see some ARP, address resolution protocol, which IP address is associated with which MAC address, and whoever accesses this information inside here from the WAN address, it translates and it goes to the person or device that is looking for that information. So network address translation solves the issue of not having enough IP addresses. IP version 4 addresses in the world, because we have over 8 billion people on this planet, but IP version 4 addresses, we only have about 4 billion. So one way to solve that is network address translation. So every network has a network address translation, and then you have the wide area network. So I like to put this little exercise with my students. I have them go home, and if you were to go on your computer, you open up a web browser and type in "what's my IP address" when you're at home, you'll actually get your true IP address. Not the one internal, you'll get your true IP address, and that's the IP address that is seen on the outside of the network. So some special use of IP version 4 addresses. We have our loopback addresses, our 127.0.0.0. This is a WAC 8. And commonly identified as 127.0.0.1, used on a host to test TCP IP operation. So listen, so as far as the loopback is concerned, this is one of those things where if you want to test to make sure that your network is working, or if your NIC is working, your network interface card, you can actually ping your own loopback plug. You can ping it to see if this is actually working. That's one lazy way to do it, I think. I think the best way to do it is to actually go back behind your machine and take a look to see if it's physically unplugged, right? By the way, if something is physically unplugged, what layer of the OSI layer does that deal with? Send me an email on that one. Make sure we understand this. Now, our 169 right here, .254.0, this is very important, because in the IT world, there has been so many calls, so many tech calls, or what's the word I'm looking for, work orders, where people are saying that they can't get out, the computers are not working, things of that nature. So the first thing I do on the computer is do an ipconfig/all, look at all the IP configurations, and sometimes, a lot of the times, I would get this 169. So this 169 essentially means it's in a PIPA, which is automatic private addressing. If it cannot get its IP address, if DHCP, okay, Data Host Connection Protocol, if it cannot get an IP address to get out, right? If a brand new house gets built and does not get assigned an address so people can see that house or that address, it is going to automatically assign itself its own IP address, and that's typically a 169. You will see that a lot, especially when you hook up a computer. As soon as you open it up, the computer wants to get out to the internet, and there needs to be a DHCP protocol or some type of server that's handing out those IP addresses and says, hey, here you go. You can get out to the internet. Here's your IP address. This is the subnet that we're on. Here's the gateway, the router. Here you go, and have fun. But if you can't get to it, it's going to be on the 169. So these are the different classes when it comes to the IP addresses. Okay, we have Class A, Class B, Class C, Class D, and a Class E. Class 4 addressing wasted many IP version 4 addresses. Okay. Oh, let me go back to this. I want you all to see this. So Class A, look at the total amount of hosts that you can have with the Class A. That's a lot. Look at the Class B or WAC 16. You can have just about 16,000 networks over 65,000 hosts. Class C, you can have about a total of 2 million networks, but only 254 hosts, right? Only 254. So as you can see, you're going to get a whole lot more networks, a lot more hosts and networks with these Class B and Class A. Typically, in big businesses, you're going to see things subnetted out in a Class B because it gives you the maximum. Well, not maximum, it just gives you a lot more options, a lot more flexibility when it comes to IP addressing. The Internet Assigned Numbers Authority, or INA, allocates blocks of IP version 4 and IP version 6 addresses to 5 regional internet registries. And as you can see here, these are all the different registries that are out there. Network segmentation. Many protocols use broadcast or multicast, ARP, uses broadcast to locate other devices' hosts and sends DHCP discovery broadcast to locate the DHCP server. So that's essentially what I was just mentioning earlier. You know, when a brand new IoT device or machine comes onto the network, or if you were to bring BYOD, a computer, to a new network, you connect to the network, and it needs, in order for it to talk to the internet, it needs to have an IP address. So typically the DHCP server is what's going to do that. So it'll essentially ARP out there and say, hey, where is the DHCP server? I need an address because I need to get out. Switches propagate broadcasts out all interfaces except the interface on which it was received. You'll probably see that at packet tracers. Pretty cool. The only device that stops broadcasts is a router. Okay, routers do not propagate broadcasts. Each router interface connects to a broadcast domain, and broadcasts are only propagated within that specific domain. So here's the broadcast domain. Obviously, when that traffic gets to the router, there's no more broadcast there. Here's the problem with broadcast domains. Okay, with broadcast domains, excuse me. It can be a lot, right? It can be a little too much. It can be a lot of ARP going back and forth, you know, which can kind of flood the network a little bit. It's a little bit too much. So essentially the solution is to subnet it out, right? We got to make sure we can divide these different broadcast domains out. That way it can make things a little bit more simpler, make things a little bit more efficient. As you can see here, the solution is to reduce the size of the network to create smaller broadcast domains in a process called subnetting. And that's exactly what we're going to get into right now. So let's get into subnetting here in just a little bit. Let's go through this next one here. Subnetting reduces overall network traffic and improves network performance. Yes, it does. When you subnet it out, this thing's there a lot faster. There's less resources that it's going to use. It can be used to implement security policies between subnets. Subnetting reduces the number of devices affected by abnormal broadcast traffic, right? So as you can see in this, we have this office building. This is kind of what I was alluding to earlier in this video about that building with all those devices. Each floor essentially can be subnetted out. But take note, in order for a subnet to see another subnet or to get information to another subnet, you got to have a router. A router is what's going to route traffic from each subnet to different subnets. You got to have a router. So I'm going to take you through how I do my subnetting. All right, so the first thing I like to do before I do any subnetting, okay, before I even look at any IP addresses, before I look at any given IP address or what we need to subnet, anything like that, what I'm going to do right off the get-go, I'm going to write in my bit stream right underneath on the bottom part here. So I'm going to go 128, I'm going to go 64, I'm going to go 32, 16, 8, 4, 2, and 1. And directly underneath that, we're going to put the powers of 2 right underneath that. So we're going to go 255, 128, 64, 32, 16, 8, 4, and 2. Okay, so this is the powers of 2 underneath it, and on top is our bit streams, right? 128, 64, 32, 16, 8, 4, 2, and 1. So before I do anything, this is exactly what I like to do before I start any subnetting. All right, so now let's put a IP address up here. Let's do a 172.168.3.3, and we're going to call this a WAC 24. Okay. Now, if you remember a couple slides before that, I'm going to take our subnet mask, okay, and I'm going to write that out in binary. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and then these are going to be zeros. Okay, I'm just going to make these zeros, put little dots for zeros. 5, 6, 7, and 8. Since it's a WAC 24, I'm going to draw my network line right down the middle. So I know that the first 3 octets, oh, I'm sorry, I messed that up. Let me get that out of there. I apologize. That was an error. Network line is actually going to go right here because it's after the 1s. Everything else here gets a 0. So this is our network side right here. This is our network side, and this is our host bit side. So let me show you that with the laser so you can see that. Again, this is our network side, and this is our host side. And I drew the network line right down the middle. Okay, so let's go back here. Because what we need to do, I want to try to create what's called we're going to do 4 subnets. We want to create 4 subnets. 4 subnets using this given IP address. So 4 subnets using this IP address. Now, please pay attention to this because this is how I have learned it, and I'm going to teach you the way I learned it. We drew out the bit stream. 128, 64, 32, 16, 8, 4, 2, and 1, and then 255, 128, 64, 32, the powers of 2 underneath, okay? The powers of 2 numbers on the bottom, these numbers on the bottom are going to represent how many networks you can make, okay? The number that's directly associated with it, directly above it, is going to tell you how many bits it's going to cost you from the network side. Let me repeat that. Very important. Let me repeat that. The powers of 2 numbers here at the bottom. These numbers represent the networks, how many networks you can create. And the numbers directly above them from the powers of 2 tells you how many bits that it is going to cost you in order to create those networks. So, in the scenario that I just put up here, we need to create 4 subnets, okay? So this is what we're going to do. We're going to locate our subnets. So we have 2. Can we create 4 subnets out using 2? No, we cannot. So we're going to go over to 4. Can we create 4? Yes, we can. And as you see that here, it is going to cost us 2 bits. It's going to cost us 2 bits. So watch this. Our former WAC 24 is going to cost us 2 bits, now becomes a WAC 25, and now a WAC 26. Now we're at a WAC 26. WAC 26, okay? We're not done. We're almost done. Almost done, but we're not done. We need to find our increments. We need to find out what our increments can go up to because we only have 254 hosts that we can deal with, right? 255 being the broadcast, and then with 0 being the network ID. So we need to figure out our increments. And the way you do that is this. The very, very last bit that is on, what position is that in binary? What position is that in binary? It is number 64. It is number 64. Therefore, our increments are going to be 60 increments of 64. This is going to be our increments. Okay, hope you still follow me there. Hope you still follow me. Okay, so let's get our subnets drawn out. Now that we understand we have increments of 64, it is determined because of the last bit that was on, 64. Okay, we're going to do it in 4 subnets. It's going to cost us 2 bits. That's how we got it. All right, so we need to find how to get to these subnets. In order to do that, we found the increments, which is very important. But now we also need to get everything drawn out now. We have to figure out what the network ID is for each subnet, and we need to find out what the broadcast, because we can only have a maximum of 64 hosts on each network. So let's go through the first one. First, let's go through the first subnet. Put that right here. We're just going to put subnet. So true or false, send me an email on this. Can the first 3 octets change? Yes or no? Do these numbers change? Let me know what you think. You should already know, but still let me know what you think. Send me an email on that. So first subnet, it's going to be 172.168.3, and we're going to do a .0. That's going to be the lowest. Okay, because that is going to be the lowest number. Through 172.168.3.63. Very, very important. .63. Because you have to count 0 as an actual number. Okay, actual number. Let's look at the next subnet. Okay, we have, where's my pen? Here we go. So we have 172.168.3.64. Yes, right, because the last number we left off is 63. 172.168.3.127, right? See that? 127. Very, very important. 127. So the increments between these 2 numbers here, let me get my laser pointer out here. You see this? Is 64. 64 hosts. Okay? Let's continue, because we're getting close to getting done here. All right? Let's go to subnet number 3, because we're subnetting out 3 here. We have 172.168.3.128, right? .128. Very, very important. .128. Okay. And then we're going to go 172.168.3.191. That is increments of 64. There's 64 bits there, right? 64 hosts. Now let's do subnet number 4. Here's the very, very last one. 172.168.3. Oh, 3. .128. I'm sorry, not 128. .192. I'm sorry. 192, because we left off on 191. You see that there. Through 172.168.3.255. Okay? Now, watch this very carefully. I want you all to see this. Watch what I do here. Okay? This is why I like to draw it out like this. This side represents the network ID of each network. Remember, two addresses are reserved. One for the network ID, and the other one is for the broadcast. This side of the IP, this side of the network, represents the broadcast IDs for each network. And then everything in between are usable hosts. This is how I like to do my subnetting so I can see the different subnets. So if we were to take a look at this given subnet, okay, 172.168.3.3, we can see that this particular subnet would fall, this particular IP address would fall in subnet number 1. Subnet number 1. Now, here's the key. Each one of these subnets have the same subnet mask. That means the same zip code, right? But they're just in different networks. So each network is going to have the broadcast domain. Each network is going to have the network ID associated with it. So let's do another one. We're going to keep the same IP address up here, 172.168.3.3. The only thing we're going to do now is that we are going to mess with the subnet. Now we're going to call it a WAC 16. Okay, so this is the given IP address now, a WAC 16. The other one was a WAC 24. Now this one's going to be a WAC 16. So let's take a look at this one. I'm going to draw out my numbers again. We're going to go 128, 64, 32, 16, 8, 4, 2, and 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, right? And then we're going to put the powers of 2 right underneath that. 255, 128, 64, 32, 16, 8, 4, and 2. Okay? So we got that. IP address 172.168.3.3 with a WAC 16 this time. A little bit different with a WAC 16. All right. So now what I want to do is draw out my binary, subnet mask binary. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And the rest are getting zeros. 4, 5, 6, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Sorry. Yeah, there is a period in here. I apologize. Okay. So we need 4 subnets. Again, let's do 4 subnets. All right. So we have 4 subnets. So we're going to subnet out this IP address. But the only thing that's going to change again is the WAC 16. The WAC 16 is going to change. Oh, by the way, send me an email on what this WAC 16 would look like in dotted decimal. What does that email look like? Tell me what. No, send me the email. Let me know what that looks like. Okay. So we're going to draw a network line. Let me get my pen here again. Here is our network line. WAC 16, because we like to divide the network portion and the host portion. So we have our, get my laser. So we have our network side and host portion. All right. We need 4 networks. We have 4 networks. It's going to cost us 2 bits. Yes, it is. So what we're going to do, we're going to go from a WAC 16. It's going to cost us 2 bits from the network side. So we have a WAC 16, 17, and now we have a WAC 18. So let's just change this to WAC 18. Okay. And our last bit that is on is increments of 64. So we're going to do 64 again. Now, please take note. A lot of people get screwed up with this. Okay. We have 4 subnets we're trying to create. And increments, this is our increments. Increments of 64. Let me remove my face out of the way so you can actually see. There we go. So increments of 64. Here is the key thing. This is super important. Our increments, when we had the WAC 24, and we were using the very, very last octet, our increments were happening in the third octet. But because we're borrowing bits in the third octet now, okay, I'm sorry, before WAC 24, it was in the fourth octet, right? So our increments happen in the fourth octet. Now that we're borrowing bits from the third octet, our increments are going to occur in the third octet, not the fourth. Very, very important because we're borrowing bits here. So therefore, every single host bit is available to us in that fourth octet. All 254. They're all there. Everything's there. Broadcast, I mean, it's all there. So let's see what that looks like going through our subnets. So here I'm going to put subnet 1, subnet 2, subnet 3, and subnet 4. Okay? And subnet 4. All right, so let's take a look now. Remember, our increments are going to be in the third octet. So we have 172.168. Okay, now we're trying to find the lowest, right? The network ID is going to be the lowest high usable host. .0.0 through 172.168. Here goes our increments, folks. Pay attention. 63.250 and 5. Okay, you see our increments. Our increments are now occurring. Increments are now occurring in the third octet. Very important. In the third octet is when it's happening. Okay, let's do the second one now. 172. Sorry, that's a busted 7. 168. Now, where do we leave off at? .64.0 through 172.168. Okay, let's make this A2. All right, 168.127.255. Okay, here are our increments. They are occurring in the third octet because we borrowed in the third octet. Let's go to the third subnet. 172.168. Here we go. 128.0 through 172.168. Okay, .168.191 through 255. Right? Through 255. And let's do our fourth octet. 172.192.0 through 172.168. Okay. .255.25 and 5. Again, this is our network ID, net ID. Everything on this side is our broadcast ID. These IP addresses are all reserved. You can't use these two. Everything in between are usable hosts. They're all are usable hosts. So once again, make sure you understand that the increments are happening in, put my mouse out again. The increments are occurring in the third octet. Very, very important. And how we got our increments is because of the 64, right? Because it was the last bit that was on. All right. So we kind of just went over this a little bit with different WAC 16s, 24. So we'll just continue here. Here's a good indication here, or a good example of using the 10.00 network, right? Using the WAC 16, WAC 24. See how the different subnet masks change for the different IP addresses, different numbers. Folks, let me go back to this. This part is very, very important. Okay, it's super important, especially when you guys doing the skills challenge, and if you're doing things with packet tracer. If you need to subnet networks out, you got to get the IP address first. I have to do this process first before I even touch packet tracer, before I touch any device. I'm not doing any configurations unless I have this part down. I typically do this by hand because I can see it. It's easier to do it by hand. But after you start doing a little bit more, you'll start to understand, you'll start to see the different networks, and start understanding. When you look at the subnet mask, you can kind of basically see what the increments are going to be, per se. So it's pretty, as you start seeing it more. Okay, let's continue here. And this is another way of looking at all of the different hosts and the subnets. Okay, see how the borrowing bits here gives you a different number of subnets that you can get for each one. Take note of the subnet masks. Okay, typically if you were to do an IP version 4, an IP config /all, you may see some different subnet masks. You can very well look at the increments by looking at the subnet mask. Okay, definitely look at the increments. As you can see, this is a 192. We just said that this is a very, very last bit that's on, which is in the position of 64. You only can have 62 hosts, right? Because one is for the broadcast and one is for the network ID. All right, so got a little bit of practice that I want you to do. A little bit of practice. So what I want you to do is this, and I want you to send me an email with the answers with this. We have two given IP addresses, 192.168.4.16 with a WAC 16, 192.174.16.7 with a WAC 24. This is your task. Using this IP address up here, I want you to create two subnets, and I want you to send me both subnets outlining the network ID and the broadcast. And then using this IP address, a little bit tougher, I want you to create 8 subnets. Create 8 subnets. And give me the increments in that as well with the IP addresses. Okay? So hope you guys enjoyed this video, and I will see you on the next one.